Did you know that once you cross the event horizon of a black hole, you would be stretched into a long string of atoms known as spaghettification? This is the bizarre and fascinating world of black holes, celestial entities shrouded in mystery. Since their discovery, they've captivated the scientific community, posing more questions than answers. Just what are these cosmic enigmas? How do they form? For decades, scientists have proposed various theories about how these cosmic monsters come into existence. Today, we'll explore 10 of these theories. First up is the most widely accepted theory, the collapse of a massive star. Imagine a star more than 20 times the mass of our Sun, reaching the end of its life cycle. After millions of years of nuclear fusion, converting hydrogen into helium, then helium into heavier elements, the star begins to run out of fuel. At this point, the star's core, rich with iron, can no longer support the immense gravitational pull from the outer layers. This imbalance between the outward pressure generated by nuclear fusion and the inward pull of gravity causes the star to collapse in on itself. In a fraction of a second, the core contracts and the outer layers of the star come crashing down. The implosion rebounds, and the star explodes in a spectacular supernova, scattering its enriched guts across the cosmos. But what's left behind? A core so dense that not even light can escape its gravitational pull. And thus, a black hole is born. This process is known as stellar collapse, and it's the leading theory behind the formation of stellar mass black holes. These black holes, typically between 3 to 10 times the mass of our Sun, pepper the universe, hidden until they interact with other celestial bodies. So, the death of a star gives birth to a black hole, a cosmic creature that continues to baffle us with its mysteries. This theory explains the formation of stellar mass black holes, but there are other types of black holes that require different formation theories. Another popular theory is the Supernova Implosion. Picture a star, not just any star, but a massive star nearing the end of its life. It's spent millions, perhaps billions of years fusing elements in its core, creating the energy that allows it to shine brightly in the cosmos. But now it's running out of fuel. As the star exhausts its nuclear fuel, the outward pressure generated by the fusion process decreases. This allows the immense gravitational forces to take over, causing the star to contract. Now bear in mind, this isn't a gentle process. The contraction triggers a cataclysmic event, a supernova explosion. In a matter of seconds, the star releases more energy than our Sun will produce over its entire 10 billion year lifetime. The outer layers of the star are ejected into space in a brilliant display of cosmic fireworks. But what about the core? Well, it's left behind, and here's where the implosion comes in. Deprived of the counteracting force from the fusion process, the core is subjected to a tremendous gravitational pull. It begins to collapse in on itself, shrinking to a point of zero size and infinite density, a singularity. This singularity, hidden by an event horizon from which nothing can escape, not even light, is what we call a black hole. Though closely related to the stellar collapse theory, the supernova implosion theory provides a more detailed mechanism of the black hole formation. So, the birth of a black hole is not just the death of a star, it's an extraordinary transformation, a cosmic recycling of energy and matter. Let's travel back in time to the early universe where primordial black holes are believed to have formed. In the moments following the Big Bang, the universe was an incredibly dense and hot place, tumultuous with energy. It was during this period that primordial black holes might have been born. Now, unlike their stellar cousins, which are formed from the collapse of massive stars, these primordial black holes are thought to have sprung from fluctuations in the density of the universe itself. Imagine the early universe as a vast sea with waves of energy and matter rippling through it. These waves, or fluctuations, could occasionally become so intense that they would create pockets of extreme density. And it's in these pockets where the magic happens. The immense gravitational pull within these dense pockets would cause them to collapse inward, forming primordial black holes. These black holes would be much smaller than their star-born counterparts, potentially as tiny as a single atom, yet they could hold the mass of a mountain within their gravitational grasp. This is due to the incredible density of matter in the early universe. But here's the rub. Despite their intriguing nature, we've yet to find definitive evidence of primordial black holes. They remain elusive, hidden in the shadows of our understanding of the universe. Yet, the allure of their existence continues to captivate scientists and space enthusiasts alike. Although no definitive evidence of primordial black holes exists yet, they remain a fascinating concept. What if I told you that dark matter could be the key to understanding black holes? Yes, you heard it right. The enigmatic substance that we know as dark matter could be at the heart of forming black holes. Now let's dive a little deeper. Dark matter, as we know, is invisible and doesn't interact with the electromagnetic spectrum, but it exerts a gravitational pull. And it's this pull that contributes to the formation of galaxies. Imagine a substance that we can't see or touch, shaping the universe as we know it. So how does this tie in with black holes? Well, some scientists theorize that intense concentrations of dark matter could collapse under their own weight, forming what we call dark matter black holes. Unlike traditional black holes formed from stellar collapse, these wouldn't emit any light or radiation, making them incredibly hard to detect. But despite the challenges, researchers are not discouraged. They are exploring innovative ways to find these elusive dark matter black holes. For instance, they're looking for gravitational waves, tiny ripples in spacetime, that could indicate the presence of these black holes. Like primordial black holes, this theory is still speculative, but it opens up new avenues for research. And who knows? Maybe one day we'll unlock the secrets of black holes and in doing so, unravel the mysteries of the universe itself. Until then, the quest for understanding continues, fueled by our insatiable curiosity and the limitless potential of the cosmos. Imagine a cloud of gas collapsing directly into a black hole. That's the idea behind direct collapse black holes. In the vast cosmos, under certain unique conditions, something extraordinary can occur. A cloud of gas, instead of forming a star, can bypass that stage entirely and plunge straight into becoming a black hole. This is no ordinary process, and it's not something that happens frequently, but the theory of direct collapse black holes suggests that it's a possibility. The concept is somewhat like a celestial shortcut. Normally, a cloud of gas would condense, forming a star that could eventually collapse into a black hole. But in this case, the gas cloud takes a more direct route, collapsing inward under its own gravity without the intermediate star stage. It's a bit like a child prodigy skipping grades in school and heading straight to university. Here, the gas cloud, under the right conditions, skips the stellar phase and dives straight into being a black hole. So, what are these right conditions? Well, for a direct collapse to occur, the gas cloud must be exceptionally dense and cool, and there should be a lack of elements heavier than helium. These conditions are rare in the present universe, but were more common in the early universe. This theory might explain the existence of supermassive black holes in the early universe. Could these direct collapse black holes be the seeds that sprouted into the supermassive black holes we see today? The mystery continues to unfold. Between stellar black holes and supermassive black holes, there's a middle ground, the intermediate mass black holes. These cosmic phenomena are a curious blend of their smaller and larger counterparts, providing us with fascinating insights into the universe's mysteries. Intermediate mass black holes are not as universally recognized as their stellar and supermassive counterparts. They're a bit like the middle child of the black hole family, often overlooked but equally intriguing. Their mass ranges somewhere between 100 to 100,000 times the mass of our Sun. Recent studies have suggested that these black holes could be formed through the collision of stars in dense star clusters. Imagine a cosmic dance floor, crowded with stars swirling around, sometimes getting too close, leading to a spectacular collision. This intense interaction can lead to the creation of an intermediate mass black hole. These black holes have remained elusive, mainly due to their stealthy nature. They don't emit light or radiation that we can easily detect, making their discovery a cosmic game of hide and seek. However, with advancements in technology and more sensitive detection methods, we're starting to uncover these hidden gems of the universe. Why are they important, you may ask? Well, these intermediate mass black holes could hold the key to understanding the evolution of black holes. They could be the stepping stones that stellar black holes take to become the supermassive giants lurking at the centers of galaxies. Intermediate mass black holes could be the missing link between stellar and supermassive black holes. Quantum mechanics, the theory of the very small, can also have a say in the formation of black holes. In the quantum world, we're dealing with particles and energies at the tiniest scales where the rules of classical physics just can't apply. At this level, the universe is a sea of energy where particles and antiparticles pop in and out of existence in pairs, a phenomenon known as quantum fluctuation. Now imagine these fluctuations occurring near the event horizon of a black hole. The intense gravitational field can separate these pairs, with one particle falling into the black hole and the other escaping. This process, called Hawking radiation, can lead to the black hole losing more mass than it gains, causing it to shrink and eventually evaporate. But what if the fluctuation was so intense that it created a tiny black hole? Theoretically, it's possible. These quantum black holes would be incredibly small, yet massively dense. However, the same Hawking radiation that could shrink a regular black hole would cause these quantum black holes to evaporate almost instantly. And while we've yet to observe these quantum black holes, their theoretical existence opens up a whole new avenue of exploration. They could provide insights into the nature of gravity, quantum mechanics, and the relationship between the two. This could help us unlock some of the universe's deepest secrets. Though these quantum black holes would evaporate almost immediately, they could provide insights into the nature of gravity and quantum mechanics. Neutron stars, the densest objects in the universe, could also give birth to black holes. Picture an object with a mass greater than our Sun, compressed into a sphere about 20 kilometers across. That's a neutron star for you. These astronomical heavyweights are born from the remnants of massive stars after a supernova explosion, and while they're fascinating in their own right, it's their potential to evolve into black holes that are truly mind-boggling. Under certain conditions, the gravitational pull of a neutron star can become so intense that it causes the star to collapse under its own weight. In the face of such immense gravity, the star's matter is squeezed so tightly that it breaches the fabric of space-time, creating a black hole. This process is thought to occur when a neutron star accrues additional mass, either from a binary companion star or through the collision with another neutron star. But what's the evidence? Well, scientists have observed a phenomenon known as fast radio bursts. These are sudden, intense flashes of radio waves that originate from far outside our galaxy. Some theorists propose that these bursts could be the dying gasps of neutron stars collapsing into black holes. This theory could explain the formation of smaller black holes and the observed fast radio bursts. So next time you gaze up at the night sky, remember, those twinkling stars might just be the nurseries of the universe's most mysterious entities. In the realm of the multiverse theory, black holes could be gateways to other universes. This theory suggests that our universe is one of many, a single bubble in an infinite sea of realities, each with their own laws of physics. Now, imagine a black hole. Traditionally, we think of these cosmic phenomena as devourers of light and matter, but in a multiverse scenario, they might play a drastically different role. Instead of a destructive force, black holes could be creators, birthing new universes as they consume the old. Each black hole could potentially be an entrance or exit point to another universe. But how could black holes form in a multiverse? Well, the answer lies in the extreme conditions that exist within them. The immense gravitational pull of a black hole compresses matter to a point of singularity, where our understanding of physics breaks down. In this chaotic state, a new universe could be sparked into existence, separate from our own, but connected via the black hole. The implications of this theory are mind-boggling. If true, it could mean that our universe is simply one of an infinite number, each born from the remnants of another. The birth, life, and death of stars, galaxies, and even black holes could be a cyclical process, endlessly repeating across the multiverse. This is one of the most speculative theories, but it's a testament to the endless possibilities that black holes present. So there you have it, 10 theories about how black holes might form. We've examined the enigma of black holes, delving into the possibility of their formation through the collapse of massive stars or the implosion of a supernova. We've also discussed the intriguing idea of primordial black holes born in the early universe and dark matter black holes, an enigma within an enigma. Then there's the theory of direct collapse black holes, a concept that challenges our understanding of cosmic evolution. We've also ventured into the realm of intermediate mass black holes, a recent discovery that bridges the gap between smaller and supermassive black holes. Quantum fluctuation. Black holes and black holes birthed from neutron stars have also been on our theoretical journey. And finally, we touched on the multiverse theory, a tantalizing idea that suggests black holes could be gateways to other universes. As we continue to explore the universe, who knows what new theories we might uncover? Until then, the mystery of black holes continues to captivate us. Isn't it fascinating? Each theory more intriguing than the last, painting a vivid picture of the cosmos and the enigmatic black holes that lie within. As we stand on the precipice of the unknown, we are reminded of the power of human curiosity and our unending quest to understand the universe. But remember, we are all explorers in this cosmic journey, and your thoughts and theories matter just as much. So what do you think? Which theory resonates with you the most? Or perhaps you have an entirely new theory of your own? We'd love to hear your thoughts in the comments below. If you learned something new from the video and want some more amazing, fascinating facts, then please give a like to the video and share your opinions. Let's keep this conversation going and continue our collective pursuit of knowledge. Don't forget to subscribe for more such content and also share it with your friends, fellow stargazers, families, and anyone else you think would enjoy this cosmic ride. And if you enjoyed this journey into the enigma of black holes, don't forget to give this video a big thumbs up. If you haven't already, click that subscribe button and the bell icon so you won't miss any of our future interstellar journeys. We have many more mysteries of the cosmos to explore together. Remember, the power of discovery lies not just in the stars, but also in the minds of those who dare to look up and wonder. Until our next cosmic journey, keep looking up and keep questioning. The universe is waiting.